Hey guys, Mitch here. So this video is going to be on more advanced teleportation mechanics. So I have the project file that we worked on last time from the simple one. Just sitting here, it's the same thing, and we're just going to get started. So first things first is we want to create a new interface, and so I'm just going to go here, blueprints and blueprint interface, and I'm going to name that teleport interface. You name it whatever you want, and we're just going to add a new function to this. And so if we just rename this new function that it automatically creates for us to something like check location, and basically what this is going to do is we're going to put a location into this, and then the blueprint that's running it will say whether that location is good or not, and then give us a good location if it is. So input is just going to be a vector, and it's going to be, just name it in, pretty imaginative, I know. So then output another vector, which is the output of this, and it'll just be the world position, and just a boolean to say whether it is valid or not. And so that's cool. And now we've done that. We're just going to set up our own custom collision profile, and so this will just be so the traces we do won't interfere with any of the other traces we might do in our game, so like for visibility or camera or something like that. So basically if we go into our editor preferences, project settings rather, and we go into our collision, and then we can set up a new trace channel. So if we go new trace channel, and we just name it a new teleport trace, and just put our default response to overlap, and we'll go in and set our settings manually. So on block call, I'm just going to double click this and we can set our defaults, and we can set this to block our teleport trace. And basically why we're doing this is just so we can make sure we can have objects in our game that don't interact with anything. So say the player can't walk on him, or AI can't run into them or something like that, or you can't shoot them, but then we can still teleport onto them. And this is going to be a bit more of a flexible system than what we did last time. I'm just going to go into invisible wall and put that as block as well, and invisible wall dynamic block. And we can change those whenever we want to if we run into any problems later down the line. So I'm just going to save that, and now I'm just going to create a little blueprint. This is going to be a basic block that we can teleport onto just for testing and whatnot. So if we create a new actor, and I call it teleport volume, and it's just going to contain a simple cube, not a basic shape, but a box collision, or we can do, yeah, let's just do box collision. And so that'd be cool. Just leave the default name, and we'll set our collision preset to block all dynamic, why not, just for testing. And now if we go into our class settings and we add our interface, so we want it to implement teleport, and so now we'll see it's added this function here, check location, which we can double click. And this is going to be really simple. It's going to give whatever location we put into it, put it out, and say it's valid. So basically we can walk on whatever we give it. And that's cool. And so just going to chuck that in the level and just scale it up a little bit, and out. And just for testing purpose, actually, I might just make this visible. So if we come down to visibility, I can turn off hidden in game, and just so we can see it while we're playing. And so now for the meaty stuff, I'm going to go into our teleport pawn, and now instead of a trace get teleport location, we're going to be a little bit fancy. I'm going to do like a little parabola that basically it's akin to shooting a projectile out from our face in this location, but in this instance, but it could be the Vive controllers or whatever you want. So it's going to shoot out basically a projectile and see what it hits, but also takes into account gravity. So you can do some cool things like get on top of ledges and stuff like that. So we're just gonna add a new function and get teleport location. And it's going to have a bit more inputs than the last one. So we're going to get our location, which is going to be a vector, and we're going to get the forward. So far it's the same as the other one, but now we're going to get a few more things. So we want the amount of steps to take, and I'll explain this in a little bit. And then we need the time step, and that's going to be a float. And then we need the speed of our trace, basically. And so if I take that, I'm just going to set up local variables for all these, just so the blueprint graph becomes a bit neater. So I'm going to make one, let's call this our initial location. And I like to do this with blueprints that are going to become like a little bit larger than most other ones. So if I just grab a sequence here, where I just create local variables for each of these input variables, just so we don't have wires going crazily everywhere. Let's go forward. Probably should just do, actually let's do velocity, and we'll do our calculation here. City, sorry, city, if I can type today. There we go. And I'm just going to grab another one, which will be our previous location. And this is just going to be for some calculations and stuff. I'll explain it a little bit later. And one more, which is going to be our time. And that's literally just going to take in our time step. So go here, and I'm going to set these up. So our initial location is our location, not doing anything to it. Our previous location, we'll set it to our initial location for at first, but we're going to have a loop in here that's going to change this value over time. And so now I set our velocity, which is basically going to be our forward vector, times by our speed. So I grab that, check that there, and our last thing, our time. Cool. And so basically we're going to loop over the steps, how many steps you want to take, and at each loop we're going to trace from our previous location to our new location, and then we're also going to add in our gravity at each thing, so it decreases on the z-axis every time. So hopefully once I do it, it makes a little bit more sense. So we're just going to add a basic for loop with a break, just so it's a little bit more efficient this way. And I'm going to start at 1 and go to the amount of steps we're going to take. And for our body, we're going to grab our velocity, and I'm going to break this out into our components. So now we have each x, y, and z. And I'm going to times this float by float. I'm just going to add 3 of these. Oh, we can add 4 actually. And I'm going to use all of them, and the y and the z. And these are going to times by our index, times by our time step. So I grab time and check that there. And so this is like how many loops we want to do is the steps, and then time step is how much time each loop represents. So if we just times that, we'll get that into the value we need. So I'm going to add these and add these. Cool. Which is what we want. And basically what I'm going to do is add in a trace, and we're going to do a line trace by channel. And it's going to trace our new teleport trace channel that we just created. And debug draw, I'm just going to, for 1 frame, just for debug purposes. And in the loop body, I'm going to drag that out and connect that. And for our start, it's going to be our previous location. And our end, we're going to make a vector and do a little bit of math, just for our, so we can calculate our velocity and our trajectory and stuff like that. So x and y are going to be pretty simple. They're just going to drag these straight in. And then our Z is going to be a little bit more complicated, but not too much so. So basically, I'm going to add a couple more pins here. There's a formula for gravity in doing projectile motion. If you've done high school physics, you probably would have done it. You can just look it up online, but it is this time value here. So it'll be t squared, so I'm just going to go t times t, times a half, so 0.5, and times our gravity value, which is 980 because centimeters. So I'm going to take this value, and then we're going to take this and subtract our gravity value here, and that'll go towards our z. And then just to make sure it's in world space, actually, I probably should add in our previous location, our initial location. There we go, that's better. Okay, I think we might be done for this little parabolic trace sort of algorithm. So if we go into our trace get teleport, I'm going to copy these nodes over from last episode. If you want to know how they work, obviously just check out the last episode. I'm going to go back and paste them into our new one. I'm just going to rework these a bit. So if I drag this out, the first thing we want to do after our trace is make sure we set our previous location, and this is just so that our loop is updating. I'm going to set it to our new calculated location here, and then I want to make sure if no, I'll just do an if here on the return value. So if we've hit something, I'm going to add a little sequence here. So we know if we hit something that there's no point continuing our trace. So I'm just going to drag this then back to our break for our for loop, and we'll continue on from there. So I'm just going to move these along a little bit. Just going to not deal with them just yet. And I want to make sure that if our normal's up, so if our normal is up, and also our actor implements our new interface, which I'm going to set that, teleport interface. And I might as well just chuck this in an and boolean. So this and this is true. We'll continue on. And basically this is just setting up things that can fall down just so we know everything is good to go when we call our function. So I'm going to grab our actor and call check location, which is what we want. I'm going to pretty things up a little bit and grab our location. I'm just going to grab it from this project here. Add a reroute just so things look nice and neat. And then our can teleport is going to be equal to our new is valid, which is what we want. And then our teleport location, we're no longer going to project it to the navigation. We're going to grab this out value, set that, add our pins, and with this we should be good to go. Okay. Now just to implement it, so if we go back into our event graph, and we can just delete this trace get teleport location and add our new parabola and chuck in our location and forward vector and hit this up. And now some good default values. I've just messed around with it a little bit before, so 10, 0.1 and say 500. Obviously just mess around it and see what works in your game. One quick thing actually, if I grab a scene component, scene, last time I was using a Vive, this time I'm using a Rift, so I'm just going to set it up just to use the Rift a little bit nicer. So if I rename this camera root, and this is just a 411 thing, you've probably seen me do it in a couple of videos before as well. So I'm just going to actually drag this up a little bit. Cool. So if I now grab this and hit play, you'll notice that we've got this little, it's hard to see on monitor, but we've got this little parabola arcing out, and then we hit our volume and we can see our trace thing, and we can click and teleport to our new thing. And it's cool because the parabola, when it goes out, so you can get on higher places. So if I look up on a place, I can get on a ledge and stuff like that, which is pretty cool. Yeah. And so one other cool thing we can do with the interface is if I go into here and I'm just going to create another one, another blueprint class, just actor, teleport cube. Name it whatever you want. This is just going to be for showing like demonstration purposes. So I'm going to add a cube, and this will be like a visible one. And say this is your ground or something like that. And I make that more like larger. And then I'm going to grab a box collision and to make that a little bit small. And I'm just set these both to blockable, and this one will be just a blockable. Cool. And basically we're going to go in and implement our interface again. So if I go here, teleport interface, and we have our check location function. And now I can go here and we do a little bit smarter things here. So this is just an example of things you can do. So I'm going to grab our box, and then I'm going to get closest point on collision, and grab a now in, and grab a now out. And then we're just going to say return value. Basically, if it is in the thing, it's going to return greater than 0. And we just want to do if it's greater than or equal to 0. If we'll just read it, and it'll show you what exactly this is doing. So that's cool. And so basically when we hit this bigger cube, it's going to call this check location function, and it's going to give us a point that's within this smaller cube. So then I can have this bigger cube we can teleport onto, but only in this smaller cube region. So if I just grab this box and again set it to visible just so I can demonstrate it. And then if I just chuck it in here, you'll be able to see if I hit play and I look over towards it. You'll see that, but white was a bad choice, but if I look here, we can get our point. If I look away, it's not really working. Okay, let's check our collision then. Q, block all. Okay, okay, teleport trace is set to overlap, so I better set that in our collision settings. That's why it can be a little bit annoying working with collision and trace channels, just because you always tend to miss a preset, but it's easy to fix, I guess. So now if we go in and check this, you'll see this cube has actually blocked our trace, so we can actually trace onto it. So now if we hit play and we look, and we see that I'm looking at this bigger cube, but it's limiting me to the bounds of the smaller cube, which I don't know, it's just a cool little thing that we can do now that we're using an interface. We have a lot more flexibility. And I can hit there and teleport, which is pretty cool. I can teleport over there to the other box, and yeah, cool. So one cool thing about this is once you use motion controllers, having the parabola arcing from the motion controller is actually pretty cool. This is the technique that Valve and stuff use in their aperture science demo for the Vive and stuff like that. So I thought it'd be fun to implement and show you guys how to do it. Yeah, thanks for watching. I'll see you in the next one.